just about the end of what I want to go over. So please do not cancel a vector v from the eigenvalue-eigenvector equation, because you'll end up with a matrix equal to a number which does not make any sense. Okay, but does everybody believe this? That this is true? And what is a to the k? 0. And so what's 0 times v? It's 0. Oh, look at that. So I have 0 here equal to, so lambda was what? Lambda was just some eigenvalue. I don't know which one. But it was some eigenvalue, and v is not 0. So what's that tell you that you could conclude? Now, more strictly speaking, lambda to the k has to be 0, but therefore lambda has to be 0. Guys, we actually proved that lambda must be 0. You could kind of approach it by contradiction and say, well, if lambda was not 0, then you'd have a non-zero number times a non-zero vector equaling the 0 vector, and then you'd have a contradiction. So you can also do it by contradiction approach, but this is a perfectly good way to do it. If you have an eigenvalue lambda, it must be 0. So this thing is true. So part B was true, part A was false. That make sense? Okay. I have only one more question. Let me write it down, and then you guys can tell me if you want me to do it or not. Because I can also quit. It's later than I thought it was going to be. But, huh? Yeah. It's because I talked for too long at the beginning about the review of everything. Yeah. Yeah, it was supposed to end about an hour ago. But that's okay. One more true-false item. Right. We'll make this one really quick. So let B n by n be invertible. And I'm going to define a transformation T from Mn of f to Mn of f via T of a matrix A, so if I input n by n matrix A, I'm going to output B inverse A B. B is invertible, remember?